Okay, so here we go. So today we're going to go ahead and write and graph a quadratic equation with the parabola of a parabola with the vertex HK. And the one or our section before this, it was with our vertex at the origin. I'll go ahead and repeat this again so you guys can go ahead and see it now through the example. But we're going to go ahead and see the vertex somewhere else other than the origin. Our parabola is not going to pass through there. Now, what have we done before? We've defined parabola. We said it was the set of all points that are equidistant from a line, which we call a directrix, and a point focus. So somebody just decided to say, hey, here's a line and here's a point. Give me all the points that are in between these two items, the line and a point. And that's where the parabola came. Now, the examples that we have here, we have systems of equations, intersecting lines. We're not interested in knowing where two lines intersect. We're interested in knowing where are all the points that exist between this line that we call a directrix and the focus. So we're going to go ahead and create distances that are perpendicular to the directrix and they are the same distance from the focus. Now, there's a special, beautiful pattern to that, which will be discovered some parabola, the equation to a parabola. And you guys remember that we went through the example. Where's my pen? That it gave us this, right? Oh, goodness gracious. Okay, so here we go. So we're going to create all those distances, guys, that we have from the directrix that are perpendicular. And they're at the same distance from the focus. From here, we're going to go ahead and create all those distances. And we see that we have our beautiful parabola created. Now, this is what we call the vertical parabola. Vertical because it's open vertically. And we have all the values in that direction as well. Now, something that I want to iterate and fix for you guys, or just tell you guys my mistake, my bad. Last time I gave you guys an example, and very similar to this, it almost looks identical, but I told you guys that the parabola was down here. Just the image. All the information was correct. It's just the image I provided with the parabola going down here, touching the directrix. It's not touching the directrix. All the points have to be equidistant. So for example, if this one measures and is perpendicular to D, let's say D, I don't know, sub N, whatever it is. This distance has to also measure D sub N. So this has to be equidistant to this here. I notice that it's a little bit off scale, but the idea still remains. Okay, so if you guys can go ahead and fix that in your notes, just this parabola, put it so that it's equidistant from the directrix and the focus. Now, similarly, we can go ahead and do that with a horizontal parabola. We have our directrix. Notice that the directrix is vertical this time, and our focus is either on the right side, or it could be on the left side of our beautiful line, right? So here we focus on we do our distances that are perpendicular from the directrix, same distance from the focus, and we create all those points, making our beautiful parabola, right? They're equidistant. So in this case, we do have that distance. Let's go ahead and say that this distance is D sub N, whatever distance it is, because there's many of them. There's millions of little points of existing between this line, our directrix, and this point. This distance has to be the same one. So these two have to be congruent in distances. All right. Okay, so we're going to go ahead and continue with that idea. Now, we're going to go ahead and now give you guys the standard form equation. This is if our vertex is in this part of our coordinate at the origin, at 0, 0. If it's stated that our graph passes or our parabola passes through the origin, then our vertex is automatically at 0, 0. So what do we do if it does not? What happens if it's not going through 0, 0? What do we say? Well, we're going to go ahead and assign a beautiful different coordinate to our vertex. And let's go ahead and say that it's in, let's say in blue. continue to do our vertex. And this time we're going to go ahead and say that it passes through a point in the H direction and in the K direction. So let's not confuse this when we were doing the transitions or transformations of our functions, but we're going to go ahead and use the same variables so that we represent that transformation, not the same transformation that we were doing back in that module. This is just a transformation, but differently. And I'm going to go ahead and tell you guys how it's applied onto parabolas. Okay, so let me go ahead and tell you guys. So a vertex, let me go ahead and define it so you guys know now. It's the highest or the lowest point of the parabola. It can be the most right or the most left point of the parabola if we have a horizontal parabola in this case. But just so you know, it is that point that reaches either the highest point, and if it's an upward parabola, it's the lowest point. If it's horizontal parabola, then it's the most left point, and the other way, it would be that point that's over here, right? That's the most right point. So it's that point that's the lowest. That's what we're going to go ahead and consider the vertex. That's where we're going to go ahead and start and then finish off the graph. Okay. All right. So we already have this information in our notebooks. Vertical parabola, horizontal parabola. This is of a standard equation form or standard form of equation of a vertical parabola and horizontal parabola with a vertex of 0, 0. Now we're going to go ahead and have that vertex of HK. And this is what's going to happen. In our X value, we're going to have H spaces. In our Y value, we're going to have K spaces that we're moving. So we're now going to write our standard form of equation for a vertical parabola with a vertex at HK like this. It's going to be X minus H squared equals 4P inside parentheses Y minus K. So the same idea is going to continue. We're just moving the direction in H for our X value, and we're moving in the direction of K in our Y value. Very similar to the transformations that we did, yet a little bit different. All right, let's go on with our horizontal parabola. And here's our beautiful picture. Now we have our horizontal parabola. We have our standard form of equation, y minus k squared equals 4p inside parentheses x minus h. Okay, I'll give you guys a little second to write this down. Let me go ahead and go on to our next concept. So in order for us to find the value of P, we have to find basically the mid segment of that direction that we're going. So if it's a vertical parabola, we're going to go ahead and focus on the values of our Y's given from the focus and the direct. Subtract those two values and divide it by 2. That's going to give us a mid value in our Y direction for our vertical parabola. Then our focus, when it's given, it's going to be very similar to our vertex, but we're going to see that our vertex, it's going to be K plus P in this case, or H. And we have to find out what the value of K is given the focus. So we're going to go ahead and do that step by step. Now, horizontal parabola, it's the other direction. So our parabola is opening horizontally. We have to find the values or that midpoint between the X distance. We take the two values, our value of the focus, X value of the focus, minus the X value of our directrix, which will be given, divide them by 2. Subtract those two, divide them by 2. Now the focus will be H plus P and K. That's the coordinates to our beautiful focus. Here goes example number 2. Example number 2 is write and graph the equation of a parabola. This time we have a focus at 4, 5, and that directrix at y equals 1. Let's go ahead and group parts first so that we know that. I'm going to go ahead and graph my directrix in green. So here it is at y equals 1. Focus, it's going to be in red. So let's see, it's at 4, 5. So 4 is here, 5 is all the way up here. So here is our beautiful focus. Now I know that my vertex is going to be somewhere in between these two items, between our directrix and our focus. So yes, we can go ahead and do the midpoint or the mid point or the mid distance between those 2 points. It should be at 4, 3. Let's go ahead and do it mathematically, algebraically, so that we can go ahead and check our work. So our focus, let me go ahead and continue doing it in red so you guys can see it. Focus, it's at h, k plus p. We need to solve for k, we need to solve for p. Before we solve for k, we need to solve for p first. So let me solve for p first. P is going to be the y value in our focus minus the y value in our directrix over 2. 5 minus 1 over 2. This is 4 over 2, which is 2. In this case, P equals 2. All right, so from here, we can go ahead and find our beautiful K in order for us to get the vertex. K is going to be added to P, and it's going to be equal to 5. All right, so let me go ahead and rewrite this. Our focus, H, or let me go ahead and just write the value of H. It's 4, K plus P, K plus 2 equals 5, right? Because we know that the focus is already given. It's 4, 5, 4, and 5. We now need to solve for K. So we can go ahead and do that work on the side. Let me do it in pink so you guys can see it. K plus 2 equals 5. Subtract 2, subtract 2. K equals positive 3. All right. So now we have our H. Now we have our K. We can go ahead and identify that vertex. That vertex is H, K. Vertex is at 4, 3. Like I said, 4, 3. And now we can go ahead and write our beautiful equation. So we have x minus h squared equals 4p y minus k. Let's go ahead and substitute the values. H is 4 squared equals 4. P in this case is not 1. In this case, it's 2. Y minus k is 3. So 3. Let's go ahead and just simplify one more step. 8y minus 3. And that's our beautiful equation. And that's a y. So here is our vertex. That midpoint, like I keep on saying, that distance continues to be the same. And we can go ahead and draw all the points that are equidistant from the directrix to the focus. Okay. One more. Yes, okay. One more. There's a lot going on. There's a lot going on. So I'm trying to take it parts by parts, differentiate its colors so you guys can take it apart or just identify everything else. So the important part is the focus. Once we notice which one is which, because right now we just have vertical parabolas. Let's see when we change it up a little bit more. Okay, let me go ahead and clear, and let's move on to example number 3. We have now the focus at -3, 8. That directrix equals positive 2. So let me go ahead and graph our directrix first. In green, it's at positive 2, so here it is. Whenever it decides to graph, there you go. Our focus is at -3, positive 8. -3, positive 8. So here it is. All right. So we know that our vertex is going to be somewhere in between these two items here, the focus and the directrix. So it's going to be opening upward. It is going to be vertical again. So let's go ahead and continue with our vertical parabola here. So we notice, or we know that our focus, it's at HK plus P. We know that the directrix is at y equals 2. So let's go ahead and substitute our values. We know that focus is at -3. K plus P has to equal 8. Let's go ahead and solve for P. So P is equal to the difference in our y values, in our focus, and the y value of our directrix. X minus 2 divided by 2. So 8 minus 2 divided by 2, which is 6. Divided by 2 is 3. So in this case, my P is 3. All right, so from here, I'm going to go back and substitute and solve for K. So let's go ahead and solve for K. K plus P equals 8. K plus 3 equals 8. I know that K is going to equal 5. All right, so we figured out what P is, what K is. Now we can go ahead and write our beautiful focus. Not focus, sorry, vertex. It's at HK. My vertex is at -3, and K is at 5. So -3, 5. Is that my midpoint? 1, 2, 3. 1, 2, 3. And yes, it is. All right. Let's go on now with writing our beautiful equation. X minus H squared equals 4P. Y minus K. All right. H is -3. So we have to be careful right here because we have X minus -3 squared. 4 times P. P in this case is 3. And Y minus 5. All right, let me go ahead and simplify one more last time. Plus negative is a positive. So we have X plus 3 in this case squared equals 12. Y minus 5. And that's our equation. So we wrote the equation, and now we can go ahead and graph. That wasn't a pretty one. All right. Any questions about this so far? When our vertical parabola, where we obtain the y value of focus subtracted from the y value of the directrix divided by 2. Now, in order for us to do a horizontal parabola, we're now going to focus on the x value of the focus and minus the x value of the directrix divided by 2. Our focus is now going to be h plus p. So the transition or the transformation is going to happen in our x direction. So therefore, the p is going to be related, or in essence, just in our x direction. Okay, so it's all in our x direction. K is going to remain the same. So very similar steps. Now, instead of using our y values, we're going to use our x values and our focus minus that directrix divided by 2, we obtain the value of P. Then we can go ahead and define or find out what the value of H is once we are given the value of P. From the focus, we're going to go ahead and use that information and then get our vertex, right? So we went over example number 1, 2, 3, and here it goes. Example number 4. Number 4 says write and graph the equation of a parabola, focus 4, 3, directrix equals 0. So first things first, let's go ahead and graph our parts. Let me grab my tools. Let me grab my focus. My focus is at 4, 3. So here's 4, positive 3. And my beautiful line, let me go ahead and say this is my focus. And my directrix is at x equals 0. So x equals 0, notice it's right here. All right, so here it is. Beautiful. So you guys know, I notice that our focus is on our right side. Therefore, our parabola should be opening towards the right. Okay, so let's go ahead and write this down. Focus, let's go ahead and find in our P. Our P then is going to be the differences in our X values. So this time, instead of using our Y values, we're going to use our X values. Why? Because we're going to have a horizontal parabola. How do we know that? We're given the directrix, X equals a number. Therefore, it's going to open with the right side. All right, so P equals the X value of our focus, 4 minus 0, and the X value of our directrix over 2. 4 over 2 gives me 2. So P in this case equals 2. Now I know that my focus is H plus P and K, right? H plus P and K. Now we know that H plus P has to equal 4, and my K value is 3. All right, so let's go ahead and do that. H plus P, H plus P, we already know that it's 2. It's going to equal 4, and my K value is the same as the focus. So let's go ahead and see 3. Let's go ahead and solve for this. Let me bring it down. Let's solve for H. Oops. Well, plus 2 is 4. Subtract 2 on both sides. We get H equals positive 2. So H is positive 2. K, we already know it's 3. Therefore, our vertex, let me go ahead and do it in green, is 2 and positive 3. Now we can go ahead and write our beautiful equation. This time we're going to have y minus k squared equals 4px minus h, not squared by itself, parentheses. Substitute the values. Y minus 3 squared equals 4p, 4 times p, p is 2, x minus 3. Let's go ahead and simplify one last time, just so we can simplify here. We have y minus 3, outside parentheses squared, equals 8x minus 3. And that's our equation. Now we have our equation. We can go ahead and graph our beautiful parabola. So opening towards our right. I know my vertex is right here at 2, 3. And I can go this direction, and I can go the opposite direction. All right. Any questions so far? So we solve for P. Then from there, we solve for H using P and our focus. We now have our vertex. Once we have the vertex, we can go ahead and substitute the values into our equation and then derive our equation from there. All right, step by step. Ready for the next one? And I apologize if I'm rushing. Okay. Thank you guys for my thumbs up. I was about to ask you guys. All right, number 5. We have our focus at 5, 4, directrix at 1. So let's go ahead and graph it first. Let's see where it's located. Focus 5, 4. Here it is. Directrix x equals 1. So x equals 1. Here is 1. X equals is going to be a vertical line, if you guys remember that. Now this parabola looks like it's going to be opening towards the right or the left. Can you guys tell me? Towards the right. That's correct. So we know that our vertex is going to be somewhere around here. It should be at 3, 4, but let's go ahead and prove it mathematically. All right, let's go ahead and do our p-value. We're going to grab our x value in our focus and the x value in our directrix. 5 minus 1 and divide them by 2. Let's see, 5 minus 1 is 4. Divided by 2 is 2. So our p-value in this case, it's 2. One more time. All right, from here, let's go ahead and solve for h. So let me go ahead and grab my focus. And this is where it might be a little bit confusing, but my focus, if you guys remember, it's h plus p and k, right? So we know that h plus p, whatever these two numbers are, it's going to equal 5. So h plus, we know that p already is 2. They're going to be equal to 5. And k is already given, which is 4. All right, so let's go ahead and bring down our little equation. H plus 2 equals 5. Subtract 2, subtract 2. H is 3. So we now have 3 as our H. We solve for P. We can go back and now derive our beautiful vertex. Vertex here in this case, HK. H is 3. K is 4. So this one remains the same Y value. Our X value is what we have in between these 2 points, right? Our directrix, the X value in the directrix, and the X value of our focus. So it should be here, 3, 4. We verified it mathematically. Now that we have everything else, we can go back and substitute into our equation. We have y minus k squared equals 4p x minus h squared. Wait, not squared. Sorry. H minus k. Okay. X minus h. Oh, goodness gracious. Let's go ahead and continue. Substitute our values. Y minus 4. K is 4. Squared equals 4p. 4p. P in this case is 2. So we know that 4 times 2 is 8. Inside parentheses, x minus h is 3. And there we go. We derived our beautiful equation, and we can go ahead and graph our beautiful parabola. So in this case, vertex is at 3, 4, and our parabola opens up this way. Any more questions? Okay, let me go ahead and save one more image of this one. And we're on to the last one. Give me a thumbs up if you're ready. Let me go ahead and clear. and move on to the last one, number 6. This one we have write and graph an equation of a parabola focus at -6, 3, directrix x equals 2. I'm going to go ahead and let you guys tell me what the value of P is. So I'm going to go ahead and graph it first, but you guys should start preparing your value of P. Let's see what you guys get. Focus is at -6, +3, right here. Directrix is at positive x equals 2, +2. So it's my vertical directrix here in this case. All right. From here, I'm going to then solve for P. What did you guys get for P? Just remember we subtract our x values. We divide them by 2. What do you guys get? Oliver says -4. Agree, disagree? Darren says -4. He seems to agree. P-value, -6 minus 2 divided by 2. We get -8 divided by 2. -4 in this case, that's correct. So can we have a negative value? Yes, we can. Now let's go ahead and substitute that value into our focus so we can solve for H. So I'll let you guys give me the value of H in this case. So our focus, H plus P. Okay. H plus P, we know it's going to equal -6. And we know that P value is -4. So H minus 4 equals -6. And my K value is 3. Let's see what you guys get for H. H equals Darren says -2. Agree, disagree? That is correct. So H equals -2 in this case. One-step equation, add 4 on both sides. H then equals -2. All right, so let's go ahead and now define our vertex. Vertex is HK. Those are the coordinates to a beautiful vertex. So we already know that H, we already solved for it, it's -2. And our K value is already given the same as our focus, 3. So we have that point, -2 and +3. So it seems about right. Same distance from our directrix from our focus. 1, 2, 3, 4. 1, 2, 3, and 4. That's correct. So now let's go ahead and write our beautiful equation. Y minus K squared equals 4P X minus H. So substitute our values. We have Y inside parentheses minus 3 squared equals 4 times -4. In this case, -16. X minus H. H is -2. So we have +2. Remember, negative and negative is positive. And that's our beautiful equation. Any questions on this one? Okay. All right. So that was pretty quick, guys. I tried to rush